chance of getting an event 1 is P. ठीक है? So weight is 1, so 1 into P. Total number of cases, let's say.
Right. I understand.
I'll probably bring it then. Just for now, just think of it as 1 into P.
Right.
Plus 0 into
that's weight.
1 minus P divided by total.
Capital N, right?
Yeah, capital N. So let's take capital N.
Sure. Yeah.
यहाँ पे you have what? N and यहाँ पे N minus N.
Okay, that's a number of
Total number of occurrences. ठीक है ना?
That's the frequency, right?
Yeah,
F.
that's the frequency. F, total frequency. So उसमें से this whole thing goes.
Right.
So you just have basically N into P upon N. So basically you're left with just P.
No, but that top N was.
That top N
frequency
is the number of occurrences of N, but then you have already considered. So when you calculate the probability, what you do in the denominator, you always have the capital N, na?
Right.
So you would actually eliminate this N. So that's why you have. I've just taken this 1, and so probably the expression for the mean would be 1 into P plus 0 into 1 minus P.
Yeah, because it is already probability.
So denominator you need not put anything. So
right.
this already has got the denominators. So your mean would be, this thing is
P.
not there at all. So your mean is P. So this kind of distribution is actually called binomial distribution, wherein you have just two
Yes or no
outcomes.
answers.
Yes or no. So P.
Okay.
And now, so your population mean is P, and I'll have to calculate the standard deviation. So the standard deviation will be what? P minus P whole square.
Okay. Understood. And by N plus 1 minus P minus P minus 1 minus P, or P plus P now in this case. It will become P minus 1 plus P.
It will become actually P.
No.
No, that
The second
the
expression.
second expression will be P minus 1 plus P.
Yeah. So if you break this down and calculate, you will arrive at this expression. I'm not going into there. And if you calculate, standard deviation is always square root, so you'll have the square. So this square breaks down. You have P into 1 minus P.
P by root.
Do you want, then maybe we can just calculate breaking down and everything. That's okay, right? I guess we was not going into the details of the distribution. So that's how you get the distribution which is given there. That the population mean is P and the variance.
This is for the binomial distribution, right?
This is for the binomial.
Not the normal distribution.
This is not for normal distribution.
Okay.
This is binomial.
Because there we have those mu and sigma. We
Yeah.
have a different notation here.
I don't know why they all of a sudden brought this P to explain the confidence intervals. Confidence intervals actually could have been explained from the continuation of control limits only. You have understood the control limits, right? Which is mu plus minus 3 sigma by root n.
Correct.
Now, the meaning of confidence interval is that, if I draw some inference, about a sample, that this sample is okay, okay? This sample is not okay, or this sample is okay. I am doing it basis again that simple concept of 3 sigma. Okay? What are my chances that the samples would conform to the norm?
So basically,
It is to that we say that ठीक है, 95% confidence limits or confidence intervals.
That the mean and the standard deviation of the sample will fall within this range.
Within this range.
A mean.
Or 95% out of 100,
Mhm.
your samples and your population would be representative. Whatever way you look around, basically,
Mhm.
from the control limits point of view, you say that ठीक है, the samples conform to the population
Mhm.
95 out of 100 times.
Okay.
That
Makes
is.
sense.
So when you talk of this distribution, you would have what? You would have, so in place of mu, you have p plus minus 3 sigma by root n.
I think it's just because the only conclusion you are drawing here is whether it falls
Or whether it
does not.
It
So
does
just two, and that's how.
So you have a 5% cases
that it will not.
that it will not.
95%
Cases it will.
Okay, and that is why your binomial distribution.
Any distribution. So in binomial distribution, you just, so here I had mu plus minus 3 sigma by root n.
Mm-hmm.
In binomial distribution, I have this whole thing p into 1 minus p upon n.
Right.
So this is my population, this thing.
Okay, understood. Got it. Makes sense.
Clear?
Yeah.
I think we'll stop here.
It's been wonderful. Amazing 2-hour session. Thanks, Shanko.
Hey,
Did I say it
don't
right?
Thanks, it's like
Did I say it right? Shanko.
Shanko, yeah.
Yeah, got it.